What occurred before the huge explosion is the most troublesome inquiry today. With the Hubble telescope, we can see in excess of 100 billion cosmic systems, and every one of them may contain many billions of stars. But how did this happen? Why is there something rather than nothing? This question poses a major issue for many religions. It appears that somebody wanted to create a universe, but how could all of this arise from nothing? If you like our videos, please give us a thumbs up and subscribe to Just Space. Get excited for the videos that will be waiting for you in the future. Let us begin the journey through the infinity of the universe. In 1926, Edwin Hubble discovered that our universe isn't the only one. After an additional 3 years, he found that different galaxies were moving away from us. After this amazing discovery, it seemed we were at the center of the universe. However, Hubble's observations suggest that the universe is generally expanding, regardless of which galaxy you observe it from. All that surrounds us has a past: humanity, the diverse flora and fauna, the air and seas, the land, and planet Earth itself. The Sun is slightly older than the Earth, and the galaxy is much older than the Sun. So, both the Earth and the Sun have their own past, as does the universe that appeared around 10 to 12 billion years ago. When people first learned about the Big Bang, they wondered, what happened here? This simple question can be asked by anyone. In reality, however, this is perhaps the most challenging inquiry. So far, no one has been able to answer it definitively. This situation has not quite suited scientists, as they were accustomed to finding answers to various questions, even extremely difficult ones. At some point, scientists received not one, but a whole series of answers that were quite unusual and endless for ordinary people. An exceptional event in the history of the universe, the primary response was that there was nothing at all before the Big Bang. Incidentally, the universe arose from nothing, implying that everything came from nothing. It is unimaginable to envision when and why this could happen. Everyone will say that not only can you not create a universe from nothing, but you couldn't even make a stool from nothing. The fact that there were possibly recognizable forms of substance in the strange nothingness makes it conceivable. However, it was not entirely empty, and there were some processes that could lead to small explosions and eventually to the Big Bang. To find confirmation of this theory, scientists are trying to create something akin to nothing. They've built extraordinary chambers from which matter particles were removed, lowered the temperature, and nearly reached the cold of space. It turns out that the subsequent nothing, after all, represents something and can be investigated in different ways. Rivals of this theory respond to the subject of what occurred before the Big Bang in totally different ways. The principal thought is that the Big Bang was an extraordinary event in the history of the universe, but the universe existed before that. So far, little can be said about what this precursor of our universe was like. However, it can be expected that something occurred in history that led to the Big Bang that created our universe. Many concur, of course. There are other suppositions as well. Perhaps there was a universe before the Big Bang that was like our own, or perhaps not similar at all. We can also speculate that before our universe, there were indeed two different universes whose crashes led to the Big Bang. Finally, it can be accepted, and some moreover agree, that a genuinely unimaginable event occurred in the first moment of our universe's history. The infant universe expanded rapidly to gigantic sizes, making bubbles from which unique universes grew in a steady progression. This is how the great universe, also known as the multiverse, appeared. Assuming this is valid, just as our universe is one of the billions of galaxies known to us today, our universe is one of many other universes that are totally unknown to us. Let us imagine that different universes are indistinguishable or similar to our own, composed of numerous galaxies, stars, and planets. There are so many planets that in some of them, there is intelligent life. Their inhabitants reached an extremely high level of development and became masters of their universe. Obviously, they managed to fly from their planets to distant stars around which planets revolve, just as our planet moves around the Sun. Progressively, they also mastered numerous planetary systems in their galaxy, and then, of course, encountered nearby aliens. Everything can be totally different if there are universes in the multiverse that are entirely different from our own. Indeed, even science fiction creators find it hard to imagine what is happening in these universes, and if there is life in them, what it is like and what actions its occupants are prepared to take. Clearly, not all people believe in the Big Bang and Darwin's theory of evolution. However, for most cosmologists and those close to science, the Big Bang is now a generally accepted model for the early development of the universe. The facts confirm that cosmology as a science was only defined in the first half of the 20th century. Before that, due to a lack of evidence, many researchers had developed knowledge at the level of theory and unwarranted speculations. Significant revelations in cosmology, such as the arrangements in Einstein's situation that led physicists to the possibility of singularity, the displacement of galaxies found by Edwin Hubble, and ultimately the Big Bang, were discovered over a long time ago. Over the last 50 years, current investigations on cosmic background radiation, the structure of the universe, dark matter, etc., have been conducted, confirming and expanding prior advancements. This year, the physicist James Peebles received the Nobel Prize for this. The primary evidence of the Big Bang and the expansion of the universe was the discovery of cosmic microwave background radiation, the microwave relic that survived from the matter created in the early stages of the universe's formation. This radiation reveals hot and cold regions in the early universe. Researchers studied the cosmic background radiation, the processes of particle development and spread, reaching conclusions about the Big Bang and its rough timeline. The universe is now progressively expanding further. It is astonishing that the initial development of the universe and the Big Bang are not the final explanatory processes. According to researchers, the universe is currently gradually extending further. According to researchers, the density of matter in the universe is slightly higher than previously expected, and thus gravity should prevail in the expansion model, which supposedly turned all of space around us into a closed loop. Rivals of this hypothesis argued that it is merely an error in the calculations, as the cosmic background radiation is a vast amount of data that undoubtedly cannot be decoded 100% accurately. If the creators of the closed universe study are correct, this undermines not only current cosmological theories but also the laws of physics and mathematics. It is not a reality that in the existing expansion hypothesis of the universe, researchers have not yet considered extraordinary matter that would account for the effects of gravity and confirm that space is indeed infinite. During the 1960s, Americans Arno Penzias and Robert Wilson discovered cosmic microwave background radiation, or cosmic background radiation noise, that fills the universe evenly. This showed that space is not dead and cold, with zero readings for temperature and energy, but is filled with cosmic background radiation that warms the room temperature to negative 270 degrees Celsius or about minus 454 degrees Fahrenheit. This leftover heat is proof of the hotter condition of the universe after the Big Bang. Among the inquiries that particularly stressed cosmologists were, for instance, the topic of the development of structure in the universe, how and why galaxies and their clusters could form due to the Big Bang, and how small variances in the development process led to such complex designs that we are currently observing. The second question, which is very connected with the first, concerns the properties of the cosmic background radiation found in 1965 by radio astronomers Arno Penzias and Robert Wilson. When it was discovered, scholars determined what properties this radiation ought to have and what that says about the beginning of the universe. The age of the universe, the Big Bang theory, and later observations of the expanding universe allow us to calculate the age of the universe. If we calculate the time it takes for the universe to develop from a point to its current size at a specific rate of development called the Hubble constant, and also take into account its temperature, we can assume that the age of the universe is around 14 billion years, give or take 1 billion. This conclusion is confirmed by cosmic observations of the oldest objects in the universe. These are primarily small stars with a low rate of burning. However, they could not have formed sooner than 500 million years after the Big Bang. So, it was difficult to determine the age of the universe from them precisely, being estimated now at 13.8 billion years old. The theory of the universe's origin is something more than a straightforward description of the expansion of the universe from a small point to its current massive size. A series of events that transformed its initial state, determining the structure of matter and the construction of the universe. All of this occurred in the time between the first inconsequential parts of a millisecond up to 1 minute after the Big Bang. Without diving deep, we can assume that the universe was extraordinarily dense and hot in its early stages, a small bundle of pure epic energy. As it expanded and cooled, different states of matter, energy, and even forces of nature appeared. This process enigmatically resembles the cooling of steam and its transformation into water and then into ice. Each stage leads to a change in the state of matter, gaseous, liquid, or solid. This is called phase transition. However, in the early stages of the universe, the advances were much stronger. We don't really know anything about the initial state from which they began. 3 significant